In today's world, missiles are the main tool to defeat the enemy. A missile is a weapon that can destroy an enemy in any situation, near or far, stationary or moving. Since the use of nuclear bombs is prohibited, missiles have become a popular weapon for all. Today we will know through this video, how does the missile work? What is the basic physics behind it? All issues have been discussed. Missiles are basically two types, ballistic missiles and cruise missiles. The biggest difference between the two missiles is that after the launch of the ballistic missile, it cannot be controlled anymore, also called unguided missiles. That is why ballistic missiles are used to destroy stationary objects, such as enemy bases, buildings, and various installations. On the other hand, cruise missiles can be controlled even after launch, which is also called guided missiles. Cruise missiles are able to lock the enemy and chase after it. So usually cruiser missiles are most commonly used to destroy any moving objects, as well as to destroy stationary objects. Besides, all the other features of both missiles are almost the same. So today we will discuss in detail how the cruise missile works in this video. Let's discuss its structure first. All the components inside the missile are covered with a strong steel case. Its front part is made very precise, so that the speed does not slow down due to air barriers. Due to its smoothness, it is able to cross air barriers very easily. As a result, it can travel at high speed with little energy. These are electronic wings. By changing the position of these wings, the missile can move right, left, up and down. And these fins are used to keep the missiles in a more stable condition. They are connected to the body of the missile in a fixed state. Very back of the missile is the nozzle. Let's take a look at the inside of the missile and explore every part of it. Missiles are usually divided into three parts. The first part consists of detectors and informational devices, then the explosive substance, and lastly the fuel. The seeker is at the front of the missile. Seeker is essential for the performance of missiles. It is associated with thermal imaging cameras, infrared imaging, stabilization, high accuracy, inertial navigation, etc. Tracking the moving enemy is possible only through the seeker. This is the control system. The control system directs the missile to the correct flight path using information from the seeker. Next is the warhead or explosive cylinder. Commonly used as explosives are TNT, RDX, Shido, Azido, Azide, etc. Some missiles also use small amounts of uranium to increase the destructive power of the missile at an even greater rate. And the last part is the rocket fuel. Generally, two types of fuel are used, solid and liquid. Most missiles use only solid fuel in their propulsion systems. Metal powders such as aluminium often serve as the fuel. And ammonium perchlorate, which is a mixture of perchloric acid and ammonia salts, is the most common oxidizer. Oxidizers are substances that help fuel burn. The fuel and oxidizer are packed together in a metal casing. This is electrical ignition. When it is ignited, the combustion process begins in the propellant. The propellant mixture is housed inside a strong case known as the motor case. This motor case plays an important role because it acts as a very powerful pressure vessel. Inside it, solid fuel and oxidizer react and complete the combustion process. When the propellant starts burning, high-temperature combustion gases are produced. The produced gas flows through the nozzle. This nozzle is designed to accelerate the gas flow. The rocket's propulsion system comes to life when the combustion gas flows through the nozzle. That is, Newton's third law is applied. Every action has an equal and opposite reaction. Hence, when the combustion gases are ejected backwards at high speed, an equal and opposite force is applied to the body of the missile. As a result, the missile moves forward at high speed. The speed of each missile is 2 to 3 times that of sound, and some missiles even travel faster than that. Now the question is how the missile is able to target the enemy and chase after it. Let's know the whole thing step by step. Missiles can be launched from anywhere like silo house, fighter jets, armored vehicles, etc. From wherever the missile is launched, it has a base station. The base station has a radar that emits radio waves in all directions. Each radar has a specific range. As soon as the enemy enters this range, the radar detects it. Sometimes satellite technology is used to detect the enemy or to launch intercontinental missiles. The radar then sends that information to the seeker inside the missile. Seeker locks the target object. Then the missile is pushed out by air pressure from inside the silo house. Then the electrical ignition is switched on and the missile is launched towards the target. Now the question is how the missile is able to chase the enemy and finally destroy the enemy due to the high speed of the missile. Let's explore each topic more thoroughly. On the front of the seeker is a radar, which constantly emits radio waves forward. Radio waves are a form of light that we cannot see with our eyes. When this light hits an object, it is re-reflected back to the radar. Also, the radar is made in a conical shape, so that it is possible to easily determine which direction and how many degrees the reflected light is coming from. Then the seeker sends all that information to the microcontroller. Microcontroller is a standalone computer. It is capable of accurately measuring the distance to the target object by determining the arrival and departure times of the radio waves. The microcontroller then analyzes that data to plot the easiest path and steer the missile's fins to chase down the enemy. Now the question is how the missile turns right, left, up and down at certain angles in the middle of the sky. Because turning at a certain angle must be determined relative to something. For this purpose, high-accuracy inertial navigation is used. Through inertial navigation, it is possible to easily determine which direction and how many degrees the missile is turning. When the missile follows its guided path and approaches the enemy, the missile bursts and destroys the enemy. Also, when it's necessary to intercept another missile or something smaller like that, a direct hit is almost impossible. In this case, the missile is busted when it comes within 10 to 15 meters of the enemy. Thus, a guided missile is capable of destroying the enemy with about 90% success rate. I hope you understand how missiles work. If you like the video, don't forget to subscribe and like the video and turn on the bell icon.